Hey everyone, this is my second attempt to make the blueprint reading midterm review video. I posted one last night, and when I went back to watch it after it was all done and uploaded, there was no audio on it, and that doesn't do y'all a whole lot of good. I apologize for how late this is. I know it does cut into the amount of time that you'd have to watch it and maybe rewatch it, and so I do apologize for that. I hope this one works out. Our midterm is the next session that we're going to have coming up here, and I wanted to pretty much lay out every topic that the exam is going to cover. I don't want there to be surprises. Not really into the whole like throw curveballs and see what I can kind of trip you up on. That's not the purpose of this. The things that we've gone over in class, I'm going to go through the ones that are going to appear on the midterm. They're the major topics, and assuming you're comfortable with everything that we go over here in this video, you shouldn't have any issues coming up on the next session. So I've got the exam here. I'm going to do some screen sharing so I can bounce around through our class's Blackboard page, and then also through the text. So give me a second here to get that up and running. Let's see, we'll go to session 1 here. So yeah, topics from session 1. You know, I want you guys to understand what the purpose of an engineering or a technical drawing is. Very first time we got together, we went over that in the session 1 outline. What are drawings? Right here in this first bullet, or the first bullet point's a link, but the second one says the purpose of an engineering drawing is to convey graphically the ideas and information necessary for the construction or analysis of machine structures or systems. You certainly don't have to memorize that word for word, but just understand that the purpose is to graphically convey these ideas so that we can manufacture a part. I mean, that is the purpose. The other thing that you should be brushing up on are common elements of an engineering or a technical drawing. Those are listed in bullet points on the first outline as well. Common elements would be lines, dimensions. We haven't talked about section views really in the class yet, but sections, tolerances, materials, things like that. Unit 1 of the text also goes over these common elements as well, but they're right there on the excuse me, right there on the outline for you to review. And also from session 1, an important thing that you should be prepared for with for the exam are the drawing levels. They're bullet pointed as well: conceptual, developmental, and product. Now you don't need to have a hugely great grasp of what each one of those entails. Quickly we'll go over it. You know, conceptual is your very first idea that you're going to sketch out on a piece of paper. You may have somebody make it, you may not. It's just the lowest level you can get for you to put your idea to paper. Developmental now starts introducing things like, well, what material do I want to make it out of? And I really do want to make 1 or 2 of these things, so you're putting a little bit more detail into them. And then the product level is the level at which you're going to put the entire package together and be able to ship it out to anyone in the world, and they'll be able to make your item without having to come back and ask you any questions, or there won't be any ambiguity to the item. Any competent manufacturer will be able to make it. Now, again, don't need that level of detail in understanding what each of those drawing levels are, but just know what the 3 are. Be able to identify conceptual, developmental, and product. Moving to session 2, what we want to focus on there for the exam. Let's see. Let's call up our format. I'm sorry, our outline. We want to talk about drawing formats. You want to be able to name some elements of the format. Those are bulleted here in this section. You know, we have a border and a title block. The title block being that guy down in the lower right-hand corner that has things like a drawing number and a drawing name and a scale and things of that nature. The revision block, which is in the upper right-hand corner, tracking all the changes that we're making. So be able to list out a handful of required elements of a drawing format. Also, you know, what's in a title block, the guy that's down in the lower right-hand corner. the name and address of the company that did the design, the drawing title, the drawing number, sheet revision, things like that. Be able to list a handful of those things, so be familiar with those. Common line types, which I think, yep, they're on this page 2, sheet 2 here of our session 2 outline. We hit those pretty hard: object, hidden, and center are the 3 most common line types that we've gone over thus far. Make sure you can identify those, make sure you can list those out. Let's see. Let's go over to session 3. All right, session 3 was a video lecture, but it does have a outline. Let's call that up. The very first topic here: extension, dimension, and leader lines. Be able to identify them, not necessarily list them out like we said before, like, oh, what are the 3 common line types, or what are 2 common line types, and just be able to give me names, but be able to identify these. So if you're looking at a drawing and I point to an extension line and say, hey, what kind of line is this? Let me know let me know that you know that that's an extension line. Same with dimension lines and leader lines as well. And this is handled in Unit 4 of the text if you need to go back and take a look. Unit 4 is extension lines and dimension lines. Starts right off talking about extension lines and starts giving you some examples of how they extend away from the object. And then also, let's see here, figure 4-3 points out what the dimension line is, the unbroken line there with the leader, or excuse me, the arrow at the end of it. So if I point to a line like you've got here in 4-3 and say, hey, what kind of line type is this? Be able to identify that as a dimension line. Also in session 3, let's see, let's go back to our outline. We talked about first and third angle projection. Now we're only dealing with one of those in the class, first or third. And we've gone over in the video which one we are using. We briefly talked about the other one, just to kind of give you an explanation of what the difference is. But be prepared to let me know which one of those we are working in. It's either first or third angle projection. There will be a question about that on the exam. Big chunk of your exam is going to be, let's see, let's just take off screen share here real quick. A big chunk of the exam is going to be questions based on a set of drawings that I'm going to provide you. I think it's about 5 drawings total. So everyone will have a drawing set, and you'll have a series of questions that are in reference to one of those drawings. The types of questions that you're going to be asked are everything we've gone over in class, really, like to be able to look into the title block and pull a drawing number, to be able to name the material that's being used to create that specific part. Early on, we talked about vendor item control drawings, which are documents that are used to establish a part that we're not going to make from scratch. We're going to buy it. We're going to buy it from a vendor, a screw maybe, a fan, a pump, things like that, to be able to know where to get the vendor information from off that drawing, to the vendor part number and things like that, the scale of the drawing. Let's see, pulling this right off the sheets here, guys, so you're getting it right from the exam. Being able to determine dimension values. We did a lot of class exercises and homework exercises where a dimension would maybe have a, oh, here, let's just bounce over real quick and take a look at one. Just so we're not being too ambiguous. I think actually, you know what, we'll go to the very last session that we had, because we did have an example of where we were calculating unknown dimensions, and it was in the class exercise BP17, the dovetail slide, one of the last things we did in the last class. If you look in the top view here, we had a dimension for P. Now that was an unknown. It was just labeled as P, but we can look in other views and look in that top view and look in notes and other things and determine what the value of P is. So that's going to be a question that pops up on a couple of the drawings that I give you. There'll be enough information there for you to calculate what the unknown is. So just be prepared to look around in the other views and use the information available to calculate that unknown dimension. Tolerancing. Remember the last, let's see, we can actually go right back to session 7 to our outline and take a look at unilateral and bilateral tolerancing. Remember that the dimensions that are on our drawings, if they don't have a tolerance associated with them, that falls down to the block tolerance, which is down in the title block. So it'll say 2 decimal places or 3 decimal places, and it'll give you a value. So if you don't have a tolerance right there on the view or on the part, you go to the block tolerance. But there are many, many instances where we attach specific tolerances to the dimension. And we use some terms. Here in bilateral tolerance, in this section here, unit 17, the second bullet down here says the larger size, the plus size, is called the upper limit. The smaller or the minus size is called the lower limit. So with this stack of drawings that I'm going to give you, I'm going to say, hey, go look at drawing 1, 2, 3, 4, and find this specific dimension and let me know what the upper limit of that dimension is. Let me know what the lower limit of this other dimension is. So be familiar with upper and lower limits. And we can take a look here real quick. Let's see. So for example, actually I'm going to close this down, and the one with the questions is probably what we want to use. Yeah, here we go. All right, so this one here, when we went over this exercise in class, said give the upper and lower limit, question number 5 here, says give the upper and lower limit for dimension P. Now that was one where we actually had to calculate P, which is, again, reverting back to a couple minutes ago here, you will have to do that. But when we're talking about upper and lower limits, if there's no tolerance applied there, you go up to your block tolerance or down in your title block to your block tolerance. And the upper limit is going to be whatever the plus value is, and the lower limit will be whatever the minus value is. In this particular case, it's plus or minus the same number. They're symmetrical tolerances. So let's just shift gears here. Let's just say the 7 here. What's the upper limit of the 7? Well, there's no tolerance associated with it at all. So we've got to go up here to our block tolerance. And a 2 decimal place dimension gets a plus or minus 0.01 tolerance. So the upper limit of a dimension 7.00, the upper limit would be 7.01. The lower limit would be 6.99. So be able to differentiate between upper limits and lower limits and understand what those values are. Let's see, what else do we have here on our list of fun things that we're going to do? All right. Be able to name the units of measure on a drawing, whether or not they're metric or inches. That's a very important thing to do, knowing what system you're working in. Zones, we talked about zones. Which session did we talk about zones in? I believe that would have been session 2, but let's double check. Yeah, the zoning system. So in your session 2 outline, we're kind of bouncing around a bit here. Drawing zones were indicated by the letters and the numbers that run along the top and the bottom of the drawing and along both sides. Again, with the drawing sets that I'm going to give to you, I may say, hey, on drawing 456, go to zone B4 and tell me something. Like, I'm not going to tell you exactly what, but on the exam, you'll say, go to zone B4. So you will have to know how to find zone B4. And let's see. Let's go ahead and call up that drawing. Take a look at the zones. I'll keep it kind of zoomed here. Across the top here, we see the numbers. Across the right-hand side here, we see the letters. So for example, if I was to say, what view is in zone G3, across or on the side here, we'd find the G. Across the top, we would find the 3, and we kind of follow it down and follow it over. All right, so in zone I can't speak. In zone G3, we would see view CC. So understand how to find zones using the letters and the numbers across the top and the bottom. Again, knowing where to identify materials on a drawing, whether they be in a note or in the title block. Let's see, line types again. We talked about that at the beginning of the review. If I point to a line in a drawing and say, hey, what kind of line is this? Be able to identify that line type. Know where to go to find the revision of a drawing. I say, yep, what revision is drawing 789? Know where to go to find that information. Also, let's see, session 4, we covered, let me get rid of some of these screens because they're starting to stack up on me here. All right, so back to our lecture material and session 4. 1, 2 auxiliary views. A little quick review at the top, but we did start talking about views and notes and symbology that are going to be on certain types of views. In the one view drawings in Unit 9 of the text, second bullet here, those drawings are supplemented with notes or symbols to fully describe the part, diameter symbol, radius symbol, square symbol, etc. Now remember, the diameter is the kind of circle symbol with a slash through it. The radius is just the R. Remember, the diameter is the full distance across any kind of circular feature. The radius symbol would just be identifying half of that distance. But the real important thing is to be able to identify those. So if I say, hey, what does if you see an R on a drawing, what does that mean? Well, it means radius. It's calling out a radius. If you see the circle with the slash through it for the diameter symbol, what does that mean? Well, it means a diameter. So be able to identify that kind of symbology. Also, with the one view drawings, Unit 9 in our text, let me bounce back there and get an example of what I'm going to talk about here. Okay, so in Unit 9, Figure 9-1, the B representation over here on the right-hand side, we talked about if a part is symmetrical, meaning the features on either side of the center line are the same, how do we identify that? And we said, okay, well, first of all, we want to put a center line down the middle of the part, and then we want to add these 2 lines at the bottom, 2 lines at the top. It doesn't have to be bottom and top. It can be side to side, or it can be both. It can be top to top, or top to bottom and side to side. But those marks are there to symbolize that the part is symmetrical, that everything that's happening on the right side of the center line is also happening on the left side of the center line. So remember that, and you'll be presented a view. You'll be presented an item, and the part will be presented as symmetrical, and you will have to sketch in all the required lines and elements to make that a symmetrical part. So remember, center line and your symmetry ticks, like we discussed back in session 4, to recognize that if you've just got one view, and so that you don't have to repeat dimensions on both sides of the center line, that you can use that and the symmetry ticks to indicate to whoever's reading the drawing, to whoever's making your part, that the part is in fact symmetrical. So keep that in mind, please. Session 6, there's a couple other symbols that we went over. And let's see, looks like I might have accidentally closed down my Blackboard, so let's get back to that. And we're almost done here, gang, I promise. Oh no, I've got to re-log into everything. All right, one quick second. Apologies all around, because for some reason, ALNet does not like you to be idle for very long, before it thinks that you've gotten up and walked away from your computer and doesn't want other people to jump on and get into your business. But all right, so we're back here. Let's talk about session 6 really quickly. Take a look at the class outline. had counterbore holes and countersunk holes that we went over in Unit 13. And we can jump there quickly here in our text to take a look at some of the symbology that's associated with those. Let's see. All right, yeah. Okay, so let's find the symbols. Where are you? Okay, so we talked about counterbored and countersunk holes, what that means when you're boring out the hole. In figure 13-3, down at the bottom here, you see the leader line that's coming off, letting us know that we have a diameter, that's that diameter symbol we were talking about, of 0.328, and it is countersunk, that's that V symbol, at a diameter of 0.62 and an angle of 82 degrees. So be familiar with the symbology. The countersunk symbology is essentially a V. As far as the counterbore goes, let's see if we've got one up here. Yes, all right, perfect. In 13-2, over here on the B side, that's more of the not angled portion, but a hole that's drilled down so far to meet the other diameter. So we've got a 3/8 hole. That's the main hole that goes through. The counterbore is 5/8. That's the larger hole at the top that we're going to stick like a bolt head down into to kind of sink it down into our part. And the depth, and it goes down the depth, the counterbore goes down to a depth of 5/16. So be prepared to identify these symbols. That sort of U-shaped or channel-shaped symbol for the counterbore, and this depth symbol, the arrow with the line at the top, letting us know how deep the hole is. Know what those mean. So if you're presented with either of these symbols, be able to say, okay, yep, this arrow, that means depth. This U-shaped channel kind of symbol, that means counterbore. Be ready to identify those. Lastly, again, upper and lower limits. I'm going to present you with a size of a part, and I'm going to say it can be as big as this and as small as this, and I want you to be able to put a dimension on that. Let me go back to, let's see, let's go to session 7, maybe? Do we have any examples there? Let's try 6. Let's go back to 6. Lecture 6. Any kind of examples? My goodness, I'm missing out all over the place. All right. Somewhere I had some drawing examples, and this would become very, very easy if I could just find them. All right, let's try this guy here. There we go. All right. So in this particular example, this is one of the ones that we did a sketching exercise on. Basically what I'm trying to say is I want you to be able to express something like this hole diameter here. If I say the hole is a diameter of 0.53 and it can be as big as 0.55 and as small as 0.52, write the dimension to display that. In this particular case, you could do it a couple of different ways, but to get to 0.55, you'd have a diameter of 0.53 plus 0.02. That gets you to 0.55. To get you down to 0.51, diameter of 0.53 minus 0.02 gets you down to 0.01. Those are symmetrical, so you can use a plus minus bilateral tolerance. But you could also use a non-symmetrical. So if it can go up 0.05 and down 0.02, then you need to be able to express that in a dimension. So understand what the upper and lower limits mean, and understand how to put those into a dimensional form. Fairly straightforward, but I just want to reiterate that that's absolutely something I'm going to ask you to do on the exam. So if you've got to go back and take a look at the text, or got to go back and take a look at any of the examples that we've done, please do. You'll be given the root dimension or the nominal dimension, and then you'll be given the upper limit and the lower limit and asked to express that as a dimension. So be prepared to do that. That's basically it. We are about halfway through our course right now, and we've covered the 7 sessions that we've had so far, doing line types, dimensions, views, projections, and things like that. So everything that we've gone over in this review will be on the exam. If I have bypassed or skipped over something that is in one of the outlines, for example, we went over common sheet sizes for drawings. We talked about A size, B size, C size, etc. If I didn't talk about that, which I didn't talk about those, not going to be on the exam. Doesn't mean it's not worth knowing, doesn't mean it's not worth remembering. These are all things that if you continue on in engineering technology and you get into either drafting or engineering where you are working with drawings on a daily basis, these are all important things to know, but they aren't going to be on the exam. Just the stuff we talked about tonight are the topics that you're going to need to understand well enough to be able to answer questions and to look at drawings and be able to pull information off those drawings related to the things that we've talked about in class. Again, no tricky stuff. I know the last session that we had, when we looked at that dovetail slide, there were a couple of, hey, tell me what dimension n is. And you had to do all kinds of calculations where you had to go out and back and cut something in half, and nothing like that. It'll all be very straightforward, but you will be asked to calculate dimensions, pull information from drawings. Please remember the zoning system. Please remember to go where to go in the title block in order to pull information like your scale and your material and things like that. Be familiar with those things, and you will do just fine. If you watch this video and you have any questions over the weekend, please shoot them to me. I will do my best to check my email throughout the weekend to answer any questions you might have. And also the night of the exam, if you show up early and I'm there a few minutes early and you have any last-minute questions, please don't be shy to come up and ask. I will answer absolutely anything that you have prior to handing out the exam. So if watching this video you still don't have a grasp of a certain topic or you have a question, please come up and ask. I'll be happy to answer as best as I can prior to starting the test. So I hope to see you all in the next couple of days. I hope you have a great weekend. Apologies again about the lateness of the video. I will be removing, I guess, the take one version of this video since there's no audio, and hopefully this will serve as a reasonable tool for you guys to prepare for what we're about to embark on. So I'll see you guys in a couple of days, and that's it for now.